So we saw how this basic program that takes command line arguments work. Of course, we'll use this to get inputs at the command line and then do processing. For example, some of the arguments that we pass in at the command line can be names of files that we use as input or output. It can be other inputs like integers or floating point numbers that we use as inputs to our program. The picture you want in mind when you have command line arguments is this. You have argv is an array. Each location in this array is a string, so it points you to some location where you start a null terminated string. So each one of these is a null terminated string. So even if you type in the number 1 or number 2 at the command line, what you get is a string, and you have to convert that string to a number. So that's where that short little program that you saw earlier that converts a sequence of digits might come in handy, but it turns out you don't even need that. There are standard functions that will convert a sequence of characters in a string to a single int or a double or whatever you want to convert to. Okay, so let's say you run this with just one command line argument. Like here, you just run the program with no arguments. In that case, what you have is argc will be 1, and so remember that argv goes from 0 to argc minus 1. Argc is 1, so it just goes, it's an array of one element exactly. So when you type in just the command name itself, or in this case the program name / program name, this is one string, and so this just takes up this creates an array with just one element, and that's what you have when you type in no arguments. If you type in one argument, you'll have 2 array locations. Each one of them is a string. If you have 3, it'll be 3 command line. It'll be 3 locations in this array. And you can print out each one of these arguments at the command line. That's what this does. This uses a for loop, which we haven't really used so far. Remember that, I guess we have. Remember that we tried declaring the int inside the for loop like we are used to doing in Java, and if you do that, you do have to compile with the flag -std equals C99. That's using the C99 standard rather than the default. Okay, so what this for loop does is print out each of the locations, each of the elements of this array argv. Do you have to stick to this name argc and argv? No. Typically people use shorter names like n and v, or n and argv, so on, n and a. The popular ones are, I think, a or n here and av. It doesn't really matter. You can put in whatever name you want. This is just a convention that among C programmers that you tend to use int argc * argv, but you certainly don't have to stick to those same names. As long as you're consistent, as long as you use the same names, for example here and here, you're fine. So what all this does, it'll print out all the exact command line that you type in without actually sticking to the exact spaces that so if you put multiple spaces in your command line, those spaces won't show when you print out each of the argvs. So you can try that out. But I want to move on to how to use these command line arguments when you're debugging. So remember that in GDB, when you run the program, you say run. Well, it turns out you can put in all the command line arguments when you in the run command. So when you say run and just hit return, that's like typing no command line arguments. If you say run x, y, z, or file in, file out, those two commands those two arguments go into argv. For example, file in will go into argv1 and file out will go into argv2. So let's try this out with a simple example, same one that we had before. Remember that we do have to compile this with the -g flag to enable debugging. Then we can say gdb, and we don't have to say // in this case, lec 17-8, and there it is. We can list it, but we don't need to really list it. So now let's put a breakpoint at line 4, the second printf, and let's say we run with 1, 2, 3, 4. So we're passing in 4 arguments at the command line. Okay, so what does it say? So it says printf, it hasn't done it yet. And so let's go over this. And it says, it's kind of a little bit hard to see, but it prints out the entire path. That's why it's a little hard to see. The entire path shows up as a argv sub 0. And then it says called with 4 args. The 4 comes from these 4 numbers. Let's try it again, this time with 3, 4, 5. Start it from the beginning, and we'll continue, and it says this long thing, which is the name of the program, called with 5 args. And you can go through this step by step in the debugger. Remember that the main thing to remember is that when you want to supply command line arguments in the debugger, in GDB that is, you have to say run followed by the command line arguments, and that doesn't include the name of the executable itself. So on the command line, that is at the bash prompt, we will say program name / program name usually, and then all the command line arguments. In GDB, we say run and command line arguments. Next up, so we won't get to explore this completely, but I'll just get you started. Let's say we have a string and we want to add something to it, or we want to take 2 strings and concatenate them or put them together. How do we do that? Turns out, to do stuff like that, what we need to do is use this big area of C programming called dynamic memory allocation. What that means is, where previously we were fine with allocating memory on the stack, now as soon as we want to do something as simple as concatenating 2 strings or adding something to a string, we have to use dynamic memory or memory on the heap. And that's a big topic. So that's the main thing that we'll get into next, is dynamic memory allocation using these 2 functions, malloc and free.